So we have the expression log of 3x plus 5, or the equation log of 3x plus 5 equals 7. And we want to convert that to exponential form. Now we know that log base a of b equals c means the same thing as a to the c equals b. This is by the inverse function relation. Since y equals a to the c is inverse, or let's say y equals a to the x, is inverse to the function y equals log base a of x. It's the inverse function relationship, which is what we started with when we started talking about logs and exponential functions. So what we have to identify is we have logarithmic form here. Log of 3x plus 5 equals 7. That's a log to the base a of something equals something else. So if we can identify a, b, and c, we can easily rewrite this in exponential form. Well, first thing we need to do is we need to notice that log means log base 10. So if we want to be very explicit about this, we write this. To write this in this form with an a, b, and a c, we have to put the 10 there. Now, log is understood to be log to base 10, but when you're first using these rules, you're probably going to want to write that as log base 10. Okay, so we see that a, which is the base of the log, is 10. B, which is what the log is of, is 3x plus 5. And c, which on the other side of the equal sign, is 7. So that a is 10. So now I've written this in reverse form. I've written a to this, b equals a to the c. Okay, a is 10. C is a number here, which is 7. So we have 10 to the 7th. That's our a to the c. And that equals b. B is what we took the log of. That's our 3x plus 5. So we translate this into the form 3x plus 5 equals 10 to the 7th. Okay, now we have 2 to the 5x minus 4 equals 9. Now, if you haven't already translated that, or if it's been a while since you were in class and you don't remember, and even if you do, write down what you think. Identify A, B, and C in the appropriate form, and write the other form. Okay, well, hopefully you've paused and done that. This is an exponential form. This is of the form a to the c equals b, where a equals 2, c equals 5x minus 4, and b is your 9. So we put that into logarithmic form. That's going to be log base a. Remember, we identified a, that was the base of our exponent, our exponential. That's 2, so it's log base 2 of c, which is on the other side of the equal sign. C, which is the exponent of the exponential, and it goes on the other side of the equal sign when you convert this to the log. Well, the exponent is 5x minus 4. The exponent comes out here. And then that is equal to b equal to 9. So so it's log base a of b, log base 2 of 9 equals 5x minus 4. Now, once you get used to it, you know that the base is going to go here, and that the exponent is going to be what it equals, and that the number that's equal to is going to be what you take the log of. So 2 to the 5x minus 4 equals 9 means log base 2 of 9 equals 5x minus 4. And the beauty of this is that now you've got the 5x minus 4 out of the exponent. When the 5x minus 4 was in the exponent, you couldn't touch it by doing any of the standard things you do to solve an equation. You couldn't multiply by 5, you wouldn't affect the 5x minus 4, or divide by 5. You couldn't add 4 to to that because it's in the exponent. We've got it down here, so now we're going to be able to solve this for x. Now we'll do that in another step. We want to get used to turning these rules around. Next one is natural log of 3t minus 2 equals 5. So you should do that without looking ahead. What do you do with this? Okay, well, hopefully you've done it. First of all, natural log means log base e. Remember, we want to put this log expression into the form log base a of b equals c. We can't do anything with it unless it's in that form. So we have log base e of 3t minus 2, and we easily identify that a, the base of our log, must be e, that b, the thing that we're taking the log of, is 3t minus 2, and that c, thing on the other side of the equal, is 5. Okay, so again, a was e, so it's going to go here. It's a to the c, it's going to be e to whatever was on the other side of the equal sign, that's 5. E to the 5th, then equals what was inside the log, what would the argument of the log, the 3t minus 2. So we have this. Now the other one's kind of jumbled. It's e to the 4t minus 1 equals 12. I suggest you pause, write that down, work it out, and then see what I do with it. I'm going to draw a little line of demarcation here so we can separate this problem from this. They kind of ran together. Okay, well, we have e to the 4t minus 1 equals 12. That's of this form, a to the c equals b, where a is our base, e, c is the exponent, 4t minus 1, b is 12. So we write log base a was e, so it's log base e of c. Okay, I'm sorry, it's log base a of b, okay, and b is the 12 that we had on the other side of the equal sign. And the exponent is going to be the c that's on the other side, 4t minus 1. Okay, so e to the 4t minus 1 equals 12 means log base e of 12 equals 4t minus 1. That's an inverse relationship if you think about it. Then we probably ought to write log base e as natural log. And we should do that at first in 2 steps. You don't want to skip steps because you lose track of what you're skipping. After you've done 50 of these problems, then you can start skipping things if you have a good memory and really understand what you were doing. So we write that as natural log of 12 because that's what log base e of 12 is, log base e being the natural log. And the reason we write it as a natural log is you got a natural log button on your calculator. You can't figure out the natural log of 12. You have no idea how to do it, and even if you did, you wouldn't want to do it. I know how to do it. I don't want to do it. Okay? So there we have it. If we wanted now to solve for t, we'd be able to. Add 1 to both sides, divide both sides by 4, and you would have it. Okay, well, we're not going to do that just yet. Okay, what about this one? Log base 5 of x squared minus 5x plus 6 equals 3. Well, we identify the base, that's 5, so that's going to be, anyhow, okay, that's our base, that's a. Okay, so it's going to be a raised to the c power. What's c? C is what's on the other side of the equal sign, that's 3. Now I write that 5 to the 3rd, and I put that on this side of the equal sign rather than on the left. And that equals b, b being whatever the argument is of the log, the thing in parentheses here. That's the x squared minus 5x plus 6. Okay, so what that gives us is a very simple quadratic equation. Of course, you can take 5 to the 3rd power, it's 125, and that's easy to calculate. You know, you square 5, that's 25. Well, a quarter is 25 cents. 5 quarters is $1.25. That gives you 125. And you should think these things. You know, you shouldn't rely on a calculator to do the simple arithmetic. things like taking the natural log of 12, that's not simple arithmetic. You need the calculator to do that. Okay, we have 1.07 to the t equals 2. How do we translate that? Well, that's very basically with the form a to the c equals b. And that means log base a of b equals c. Log base, I wrote that down wrong. So let me erase that. Write it down correctly. Okay? The base is 1.07, so this is the log to the base 1.07 of what? Of b, b being thing on the other side of the equal sign, that's 2, and that's going to equal t. So t is log base 107 of 2. I wrote that down in the wrong order, so I hope nobody believed me, but you know, got to be careful. Okay, well, another way, okay, so we've got t equals log base 1.07 of 2, and if we know, and we need to know, the properties of logarithms, we know that that's log of 2 over log of 1.07. And you have to be careful when you evaluate this. Don't divide 2 by 1.07. That's not what this says. It says do the log of 2 and divide it by the log of 1.07. So you have to be careful. Now once you get your result for t, you can raise 1.07 to that power and you should get 2. And that's how you check it. So after you get t, check this. Okay. Now I did something here, and I'm going to choose not to do that, not to talk about that, because it became clear in class that that was going to be a little confusing. And then I took a quick look at the book, which I do occasionally, and realized the book does it all by just these two equivalencies, and they don't apply the inverse function relationship as explicitly as I would prefer they did. Since they don't, I'm going to bypass it this time. We'll be using a different textbook next time. I will. And I believe that the textbook we're going to be using does things in a way that gives you an appreciation for the inverse functions. And skipping that really doesn't, but we're going to skip it.